freedom. And 21 years afterwards, in 2004, Professor Gross was given the Nobel Prize with Dr. Politzer and his student Frank Wilczek. So, and later on, 1984, Professor Gross was also with Harvey and Rome, had put together a anomaly-free superstring theory, which they call heterotic superstring theory. And so I'm just trying to give you an idea of what he has done. Lately, Dr. Gross has, in parallel to what Murray Gell-Mann was of course the one who named quarks, and it was about the dynamics of quarks that quantum chromodynamics of Professor Gross was supposed to explain. And therefore, Gell-Mann, after retirement from Caltech, went on to become director of the Santa Fe Institute in Nevada, in New Mexico. And now he is doing transdisciplinary work. Likewise, Professor Gross has lately gone into the directorship of the Kavli Institute of Theoretical Physics, which is, the way I look at it, is a kind of transdisciplinary institution as well. And so, to me, it is something that, well, Gell-Mann, who named quarks, and he, who explained with quantum chromodynamics, the dynamics of quarks, are both into transdisciplinary work also. And I would like to think that this afternoon we would look at things not about the stuff that he did in 1973, which nowadays is given as homework to graduate students in physics, but that he will talk about transdisciplinary work as well, which is quite important for us. And in conclusion, I want to assure him of the great esteem which he is held by the Academy, and that the Academy as an institution is completely behind what the Bridges program of the International Peace Foundation stands for. Welcome, Professor Gross.
Well, what else can I say? Dr. Nazaria already took one half of the introduction. So let me perhaps just add a detail that it involved from Hebrew University in Jerusalem in 1962, and then returned to the United States to continue his education at UC Berkeley, from where he received his PhD in physics in 1966. A year later, he left Berkeley that year to serve as a junior fellow at Harvard University. Dr. Gross began his professional teaching career at Princeton in 1969 and was appointed professor of physics in 1972. During the same period, between 1975, he also became a fellow at the Sloan Foundation, and he remained at Princeton until 1996, where he was named Eugene Higgins Professor of Physics and Thomas Jones Professor of Mathematical Physics. In 1997, he was appointed Director of the Institute of Theoretical Physics at the University of California. It's a position that he holds up to date. Professor Gross has also been a fellow of the American Physical Society, the American Academy of Arts and Sciences, and the American Association for the Advancement of Science, and a member of the National Academy of Sciences. He is the recipient of the J.J. Sakurai Prize of the American Physical Society, a MacArthur Foundation Fellowship, the Dirac Medal, the Oscar Klein Medal, and the Harvey Prize of the Technion. He has received various honorary degrees and was elected to receive France's highest scientific honor, the Grand Medal d'Or, for his contributions to the understanding of fundamental physical reality. So, having said that, and after having Mr. Dr. Masare having said the rest, I would like to invite Dr. Gross to step up to the stage and give us some remarks that would set the tone for the discussions.
Actually, I don't like to sit down while I'm talking. So welcome, everybody. I didn't exactly know what the format of this session would be like, or what to prepare. I have a lecture, I mean, you'll see in the program, The Coming Revolutions in Fundamental Physics. Well, I have a short lecture, it only runs for an hour and a half. Or I could talk more broadly about the lessons of science, but I did that this morning, and I hope many of you attended that lecture. How many actually were there this morning? Good. So I don't need to do that. And instead, we're having what is what sounds to me like a lot more fun, a dialogue, a discussion. And that's something I'm quite used to. As was explained, I'm the director of the Institute for Theoretical, the Copley Institute for Theoretical Physics. Maybe I'll tell you a bit about my institute, which is rather unusual. You know, most institutes of science, you have big buildings with laboratories and people working away on very narrowly defined projects. That's not what we do. We have what is sort of a national laboratory for theoretical physicists. Theoretical physicists don't need laboratories. They work with pencil and paper. So we have a beautiful building located about 50 meters from the Pacific Ocean in Santa Barbara, which is a beautiful place to be. And we invite something like 1,000 physicists a year from all over the world. They come, and any time we have about 100 scientists in our building, working on different programs together, collaborating on frontier areas in physics. And we interpret physics very broadly. So we will have sometimes simultaneously 3 programs going, one maybe in cosmology and astronomy, and one in string theory, and one on genetics or biology, neuroscience. I interpret physics actually as anything that physicists do, and physicists do a lot of things. So we spend our time at the Copley Institute mostly talking to each other about science. That's how theoretical scientists work. A lot of discussions and dialogues and conversations. And I participate as much as I can in as many of these programs as I can. I find it fascinating to learn about all these very different areas of science. And so I'm very used to dialoguing, and I look forward to the day's dialogue with all of you. I can see very many young students here, and as well as the people who know what E8 cross E8 is. And so let's talk, and I'd be delighted to answer your questions or have a real dialogue. So in order to begin, since usually there are a lot of shy people in the audience, I have some questions. So for the students, how many of you are interested in science? Well, that's a good portion. How many of you plan to become scientists? Wow, that's amazing. Good. Well, I'm delighted to see that, and I hope you will continue with that goal in mind and succeed. And I don't know how we're going to do this. Are you going to moderate, or I'll just ask for questions. And don't be shy. And I guess we have microphones here, right?
Yes, there are.
So if you have a question, come up to the microphone. You can stand in line. That'll make things go faster. And there's someone. Come on. No. Just walk up to, there's a microphone. The microphone's here. And there. So if you have a question, come up to the microphone and wait your turn.
So good afternoon, Professor Gross. My name is Junius Andre F. Balista, and this is my question. Publishing in international peer-reviewed journal is difficult for almost everyone, even in other countries. However, it is more so, it seems, it is more so in for our scientists coming from the Philippines, which doesn't have a long and established scientific tradition. One of our professors sometimes often half jokingly would say that maybe something's wrong. If there's something wrong, it's with our address or the name of our university. So in the spirit of what you talked about this morning about tolerance, my question goes this way. Assuming that Filipino scientists are as hardworking and as creative as other scientists in the world, how can you concretely help us in this kind of situation? Thank you.
Well, there's some truth to what you say, that, you know, when, if I receive a paper in the mail, I do tend to look at the name of the author and where she might come from, because we get so much information that whatever filters we can apply help. However, by and large, the filtering system is pretty objective. Furthermore, there is a big change nowadays. You know, in the past, when I was a student, it was very difficult because people would write papers and they would send them to journals. And unless you were part of the small club of connected people who got the preprints, you had to wait half a year until the paper was published. Nowadays, the world has become much flatter, to use Friedman's phrase. I no longer read journals, because any time in my field, and in most of physics, any time somebody finishes a paper, they put them on the internet, on what is called the archive. And there is no refereeing process, by the way. They accept all papers, unless they're totally crazy. If they're totally crazy, there's a separate part of this archive which isn't called crazy papers, it's called general physics. But even they get onto the archive. So as soon as somebody writes a paper, the next hour it's available to anyone in the world who has internet connection. Everyone is equal. It's an amazing change. And furthermore, just about anything gets onto the archive. So there no longer is that problem of making your ideas available, and, more importantly, of being able to be equal with anyone else with access to new research. However, it's still important for science to have a system of judging quality and truth, or at least reason, because otherwise we would be saturated with all sorts of stuff. And in some fields, such as medicine, it could be quite dangerous. But believe me, the situation has been enormously improved by modern technology and means of communication.